The online grind is good, my friend. The online grind is good. Let me switch over for you. Workout. Hey, Yusuf, how you doing, my friend? Let's see. Right. There it is. There it is. Oh, that's I gotta go to the other one. Let's go to the other one. That's the material. Yeah. The online grind is going okay. We got back after Labor Day weekend. Hope you had a nice Labor Day weekend. Yeah, you can certainly catch up now. I haven't announced a due date yet, so yeah, you're in good shape. You shouldn't have a problem at all. All right, as long as you're going through the a goal is a goal, Yusuf. As long as it's a goal, don't matter how you score it. A goal is a goal is a goal. Hey, Ryer, thank you for the follow. Appreciate that. Thank you so much for the follow. That's really kind of you. Yeah, Kamar, you can, man. You got lots of time to finish up. You can catch up pretty easily. Oh, okay. You're from Dylan's stream. Excellent. Hey, welcome, welcome. You're always welcome on this stream at any time. Most of the time, I'm teaching mathematics, and well, some of the time we're having just a bit of fun. Nothing wrong with that whatsoever. Thanks, River Spice. Yeah. Rip. I see, I see. Yeah, I haven't done anything yet. I haven't done anything yet, I promise you. We just have a lot of fun in Dylan streams. We do a lot of silly stuff, most definitely. That's okay, Goldmash. That's not a problem. Again, as long as you learn something in along the way, you have a little bit of fun. Ain't nothing wrong with that. Hopefully, you just have a nice time. That's all I ask. Another football quiz for me to win, or to potentially cheat at. No, I'm just kidding. Nah, you're doing fine. You're doing fine. We have I do have possible maths quizzes for you to win. I mean, if you consider that as part of the deal, you know. If you want that, that's perfectly fine. I got no problem with that. Oh man. Man, how was everybody's we don't have a quiz. So, Kamar, we don't have quizzes in this class. You got to read that syllabus, my man. There are only tests and homeworks. That's it. There are no quizzes in this class. How far are we from the first test? And when the homework is going to be due is once we finish up, let's see, chapter 4? I think chapter 4. When we're going to watch U21 game on TV. First, all right. Yeah, have fun there, Gomash. Nothing wrong with that. Yeah, so about, yeah, once we finish up chapter 4, not quite there just yet, but we're working our way getting there. So, it's not very far away. Yeah. Pretty easy. Easy peasy lemon squeezy. That's how it is right now. Like I said, I will be making an announcement here. I'm guessing it's gonna be like in another week or so, by the time we get done. So, as we still got a little bit to talk about. Sure. If I were to give an estimation on time, you know, I honestly don't know yet because it just depends on you guys' pace. So, you know, I never assume anything. I just kind of go with the flow, and then it just magically happens. That's pretty much how it is. Yep. All right. That should be fine. That should be fine. Oh man, how was everybody's weekend? I hope everybody's weekend was fantastic. Hopefully everybody had a really wonderful time. You saw the Cubs yesterday? You saw the Cubs are winning 7 in a row with a team that's like I know they're not facing the greatest competition here, but 7 in a row for a team that's supposed to underperform, two 11-game losing streaks this season, traded away most of their good players in Baez, Bryant, and Rizzo. And yeah, it's just unbelievable, man. You win 7 in a row. Tell you that's a scrappy team now. Gotta hand it to the founding, the 10,000 ways to win. I don't think you could blame Ross for that. I don't think you can blame Ross for that. Nah, I can't blame David Ross. The problem is he was facing diminishing returns with those players. I mean, yeah, you could say that Bryant's a great player, Baez is a great player, Wiz is a great player, but they're getting in their 30s. It's going to be diminishing returns over time. The contracts were worth too much, and it was time to cut bait. For what they were asking for, like as much as I love, look, at, yeah, look, I agree. The front office is not very good. I won't disagree with that. But as much as I would be like, Javi Baez is a $200 million player, I'd be like, no, Javi Baez, you're not worth $200 million. No, definitely not worth $200 million. Get out of here. I love you, Javi Baez. You're great. You're a good player, but you're not worth $200 million. Not when you hit like near 200 and you have an on-base percentage less than 300. Nah, nah, that does not worth $200 million. Yeah, front office was smart not to do that either. That's dumb. Arrieta isn't even worth $20 now. I mean, he had a great run. That 2 years, that 2 3 year stretch where he was just unstoppable. Arrieta was great, but he's not worth $200 million. No. Honestly, most players are not worth $200 million. Very few players who you can certainly say for a certainty belong in that category. Very few players. I think obviously Mike Trout has to be one of them. That's the first one on the list. Do I think Fernando Tatis is one of them? It's yet to be debated. I mean, you get $300 million, but then again, he's with the team for a very long time. So, see if that works out okay. Yeah, but pitchers are again. It's hard for a pitcher to be great for longevity. It's really hard for a pitcher to be consistent, throughout their career. Have a great one, Goldmash. Take care of yourself. It's hard for a pitcher to be consistent in this day and age. Especially now you got like, of course, you have like the ban on sticky stuff, and you have, of course, more refined mechanics. They're asking you to throw harder and things like that. 100 miles an hour. I think some guys are really good that deserve a lot of money. Like if you look at Kyle Hendricks, you're like you appreciate a guy that throws like 90, 94 at best. Um, and it's just it's refreshing to see. He's not obviously $100 million pitcher, but there you go. There's Sneaky Weasel. How we doing, Sneaky Weasel? Hello, hello, hello. Hopefully we're doing fantastic today, Sneaky Weasel. Kamar, we're talking about baseball here, Major League Baseball. Hopefully everybody had a great weekend. We're almost ready to get going here. Got about a minute to go here. I'm doing fantastic here. You know what? This weekend I saw AEW All Out. Okay, Sneaky Weasel. Watching pro wrestling this weekend. It was the absolute greatest pay-per-view I've ever seen in my life. Oh my god, that pay-per-view was so amazing. Absolutely bonkers. Man, it was absolutely bonkers. It was great. Ugh, so good. Carla, hello. Good morning. Good morning to you. How was your weekend, Carla? Hope you had a great Labor Day weekend. Hope you had a nice time spending with family. Taking care of things. I know. It was so good to see Daniel Bryan / Bryan Danielson again. But it's like first comes out Spice, first comes out Adam Cole, and you're just like, Adam Cole, baby, and you're just like, oh my god, I can't believe this is happening. And not 5 minutes later is Daniel Bryan, and you're just going absolutely bananas. Oh, it was so good. It is so lit right now. I can't even tell you, my man. I can't even tell you. It's unbelievable. My weekend was great. My weekend was wonderful, Carla. Absolutely wonderful. Got a chance to rest a little bit, watch some professional wrestling. Had a very, very good time. Just sitting and relaxing. This is my mom for a bit. There you go. All right. I think we're almost ready to go here. It's a little bit past 11, but wait here. Everybody's just starting to come in. Check that time. All right. Okay. Well, let's get going here, ladies and gentlemen. We're gonna get started here. Let's do some intros, and we will get moving, okay? Let's do it. All right, let's do it, ladies and gentlemen. Let's do some intros. Okay, let's get started today. Welcome back to Tuesday. Hope you're having a nice Labor Day weekend. All right. So for today, ladies and gentlemen, we're going to continue to be moving forward here within Chapter 3. Okay, Chapter 3 is where we left off last time. Last time we talked about, again, we've talked about how to arrange data and stem and leaf plots and histograms and the whole 9 yards. We last talked about, again, standard deviation, how to find standard deviation, and exactly what standard deviation was all about. Again, how far away on average are data items away from the mean of the data set. All right, so we did talk about those here. Now today, we're going to be finishing up the handout from last time, the last 2 questions here. One of the questions will be a little bit more important than the other, at least in my opinion. But at least it will talk about one of the things that we've actually discussed in the past couple of classes, kind of putting 2 and 2 together here, to say the least. Let's go ahead and take a look here and what that is. Hopefully I should probably bring it up too. Here we go. All right. So let's bring this up here. We have question number 10 here from the previous handout, as we did finish up last time on that. All right. So let's take a good look here at, again, we finished last time on this stuff here. So is what it is. All right. So let's look at number 10. Number 10 says, what is the 68, 95, 99.7 rule? All right. Now, one of the things that we discussed last week was in regards to the normal distribution, i.e. the bell-shaped curve. Now, if you recall here, this is, again, the most probably, we talked about this type of distribution, and we didn't really talk about it in too much detail. We just said, hey, it looks like a bell-shaped curve if you put it in a curved format. So let's take a look at it just like so. Right? And it's not as hard as it may make it out to be, but we're just going to draw it out here for number 10. All right. Actually, all right. So let's say this is our bell-shaped curve. All right. So here's our bell-shaped curve just like this. Now, one of the nice things about a normal distribution here is that a normal distribution is extremely predictable. Why is a normal distribution the most ideal of conditions? Why is it something that we want to look at here? The reason why it's ideal is because of its predictability. Why is it predictable? Well, if you take this curve here and you literally, and I literally mean literally, if you literally cut this in half, you can cut this in half and have a perfectly symmetrical curve, meaning you have 50% on the right and 50% on the left. The question is, where do you cut? Well, you cut here, right here at the mean. So this is the mean here, right smack dab in the middle. All right. So this is the mean. There you go. Easy peasy lemon squeezy. Okay. Now, what you can do here is that you can go to the left and to the right here on this particular curve. So we want to be methodical about it, of course, and that is if we go down here and we take that mean, say we take that mean here of x bar, and we add 1 standard deviation. All right, so 1 standard deviation. All right, so 1 standard deviation. Again, as a reminder here, this row x here, again, you'll see that as a standard deviation, or again, sx, again, just another way, whichever way you want to call it. Anyway, this will be adding 1 standard deviation. We can also go to the left here also as well. We could take this mean and subtract by 1 standard deviation. So minus 1 standard deviation. All right. Now, we can actually keep going if we like, and that is exactly what we're going to do here. So I'm going to mark this in green. We can go the mean plus 2 standard deviations. So the mean plus 2 standard deviations, just like so. All right, so I'm just going to label it like so. We could also go backwards here as the mean minus 2 standard deviations. All right, so the mean minus 2 standard deviations. There we go. All right. We could even take it 1 step further than that. Yes, folks, there is 1 step further than that. We'll put this in orange. You take this 1 step further, I can go the mean orange is yellowish. Anyway, we could go to the mean plus 3 standard deviations or the mean minus 3 standard deviations. Okay. All right, and there we go. We got it. All right, so you're probably wondering, you're looking at this graph here on the screen, you're like, hold up a second, what does this exactly mean? All right, this just looks like random colors you kind of threw on a graph and then you magically made some kind of magical picture. I'd be like, yeah, you know what? That's kind of fair for you to say. But there is definitely a meaning behind each one, so let's discuss that here. Now, take a look at the question itself. That's actually going to be the most important part here. So if we take a look at the question here, I'm going to kind of reveal it up here a little bit. As you see here on the top of the screen, it says, what is the 68, 95, 99.7 rule? Each one of these numbers in the question itself does significantly have a meaning. In fact, each one of these numbers that you hear, 65, 68, 95, and 99.7, are each percentages that will reflect something within the graph. It's something within this normal distribution that you see here. So here's how it works. It's fairly simple. Let's say we're looking within one standard deviation of the mean. Well, if we go from this first purple line to this second purple line, so between -1 standard deviation and +1 standard deviation, what we're going to have here is that we can say that 68% of all data items in the data set are within one standard deviation of the mean. Okay, so that's essentially what that means, is that this is -1 standard deviation. Actually, that a little bit nicer. I'll put this a bit nicer for you guys. Plus here, minus here. There we are. Okay, that'll make it a little bit easier. All right, and so there you go. 68% of all data items in the data set are within, this should be data set, are within one standard deviation of the mean. All right, now that's within just between those two purple lines. Now, that represents, again, within one standard deviation. Now, if we took it one extra step and we said within 2 standard deviations, we go from this green line over to this green line. This represents the next number here. This will represent 95%. So you could say, again, 95% of all data items in the data set are within 2 standard deviations of the mean. Okay, so as you can see here, again, you just include a bigger number of data items, again, as you expand out on the curve. Between these yellow lines or orange lines, whatever one you want to call it here, again, you're including a bigger piece of the curve. So then this is going to represent 99.7% of all data items in the data set are within 3 standard deviations of the mean. Okay. Okay. Now, you can be a little bit, this is even more predictable than you think. Let's talk about that here for a second. Because in a normal distribution is perfectly symmetrical. So everything is symmetrical here, meaning, like I said, if you cut it in half here at the mean, you have 50% on the right and 50% on the left. Okay, so if I were to look at 68% here between these two purple lines, so this and this, these both would have the same exact percentage at the end of the day, since it's symmetrical, even between these two bars. So you take 68% and you divide it by 2, you cut it in half, and so what you can have is, if you wanted to look, this would be 34% and 34%. Again, just based on symmetry, 68 divided by 2 would be 34% in each one of these bars here. You can go a step further. If you go a step further, be like, okay, well, what about these two bars? What about the percentage in each of these bars? Well, what you can do here is you can take 95%, you can subtract it by 68, which is 27. 27 divided by 2 will be 13.5% in each of these bars. Okay, you can go again that step further. 99.7 minus 95 is 4.7%. Divide that by 2, you get 2.35% for each of these. Finally, we do want to represent the finally, you want to represent the 100%. So again, that's going to be 100 minus 99.7%. So that's going to be 0.3%. So that's going to divide that by 2. 0.15 on each of these. What would you like me to repeat, Kamar? Regarding which part there? If you're talking about the percentages there, just let me know. Because if we're talking about the percentages here, then again, you have to use the idea that the normal distribution is perfectly symmetrical. So you'll have equal halves regardless of how you cut it in half. So if you cut it in half, you're going to have an equal half. Okay, that's fine. So again, based on symmetry here, right? All right, so guys, based on the normal distribution, you have perfect symmetry, meaning you'll have 50% on the right of this dotted line, much as you'll have 50% on the left of this dotted line. Now, since based on this rule here, you know that between these two purple bars, you're going to have 68%. That's what the rule says. So, basically, if we know that everything is symmetrical, that means that all I have to do is take 68% and cut it in half. 68 divided by 2 is 34%, which is why I get 34 on the left and 34 on the right. That's how I know that those two numbers are there in those particular spots. Again, just based on the fact of the predictability of the normal distribution being perfectly symmetrical. Then all I had to do is, in order to get the next number here, I took the 95 minus 68, that's 27, and then I divided that by 2, and then that's where I get the 13.5 in both of those bars there. So I just kind of used my rules here, again using the percentages, and then I subtracted again, and then I was able to just cut that by 2, divide it by 2, sorry, and I got these percentages here in each of the bars, and I just kept going my way down. Again, 99.7 minus 95, 4.7%, divide by 2, and I got 2.35%, and finally the last 0.3%, divide that by 2, I got 0.15 as my final two bars right here. Are there any questions about that? Any questions? Yes. If you have a question, Kamar, then ask. That's fine. No problem, Jasmine. You're fine. That's correct. Yes, that's right. So 99.7 minus 95, right? We have 4.7. And 4.7 divided by 2 equals 2.35. Then all I did was take the last part, the 100%, to 100 minus 99.7. Okay, cool. All right. Okay. Well. All right. Let's go ahead and look above there, Kamar. 99.7 minus 95. That's where I got the 4.7 from. All right. All right. Let's take a good look here at the next one here. Um, let's actually look at an example really quick. And so, okay. So we'll do a quick example here. Let's say we have a normal distribution, just like this. Okay, so let's say we have a normal distribution. So let's go with a normal distribution. Let's say we have a mean of, let's say, 10 and a standard deviation of 2. Okay. So let's say our mean is 10 and a standard deviation of 2. And let's say I just ask you a simple question. I said, well, what's the percentage of data items? So the percent of data items, let's say between, let's go with, let's go between 10 and 14. Okay, so what's the percentage of data items between 10 and 14? Now you're probably looking at this and you're like saying, well, hold up, how do I go ahead and find that out just with this information? Well, we're going to use this little chart that you see up here. Again, we're going to use this little curve that we've just drawn in here in order to answer that question. Again, between 10 and 14. Now, the way you do this is to actually visualize it out. Now, how do you do that? Well, let's just start off with what we have here. Again, we're given a mean here of 10. So 10 here is going to go smack dab here in the middle. Okay, so that's perfectly fine. Now, if I go one standard deviation, if I add one standard deviation here to the right, if I add one standard deviation here, what number should I have here in this case? You type that out in the chat. What number should I have here in this case if I add by one standard deviation? So I should get 12? Okay, that's correct. I should get 12 here. So my standard deviation here is 2. So if I'm adding one standard deviation, 10 plus 2 is 12. Seems fair. Let's say I'm adding 2 standard deviations. So I'm adding another standard deviation here. What number should I have next to 12? Okay, 14. Good. And the number next to 14 should be just another 2 up. That should be 16, right? Should be pretty easy. There you go. Okay. 16, absolutely. Absolutely. Let's go the other direction, guys. If I subtract by one standard deviation, what should I have here in this case? All right. I take 10 minus 2 now. That's right. And I should get 8. That's correct. Very good. If I subtract by another standard deviation, what should I get? 6. Okay, good. And I think you can guess if you subtract by one more, you get 4. All right. So just based on this random scenario here, this is what the pattern should look like here with the given mean and standard deviation. All right, seems fair. Now, this will help us answer the question here of what's the percentage of data items between 10 and 14. So if we take a look here, 10 is smack dab in the middle. That's going to be our mean. And 14 is located right here. Again, that's going to be this second line here, this green line here, which is 2 standard deviations. All right, so 10 is over here, this dotted line, and 14 is right here, which is this green line here, representative. So all we have to do is add up the percentages between the dotted red line and the green line here. So that's going to be, in this case here, 34 plus 13.5. And so here you're going to get 47.5. So 47.5%, according to this rule, is what you would get. Okay? Any questions about that? Hopefully that isn't too bad. I don't count the 2.35 because that's to the right of that green line there, Sarah. So it's not, so when I say 10, 10 is here, this dotted red line, and 14 is right here. So it's not after 14, it's before 14, right? Because it's like between 10 and 14. So that's why I'm not including the 2.35 here. That would be a mistake. That would mean you're including things after 14. That's not what you want. Yeah, don't fall for that trap there, Sarah. Just be a little careful about that. Let's try one more here. And then we'll move forward. How about between actually, let me put it this way. I think I have a better way instead of between. About more than 8. How about more than 8? Okay. We take a look at just more than 8, right? So if we take a look at more than 8, all we have to do here is then look at where 8 is located. 8 is located right here where this first purple line is. And then we're just going to take every percentage after that. So after this first purple line. So 34, 34, 13.5, 2.35, and 0.15. All right. Add up all those percentages. All right. Can anybody tell me what we get here if we add up these percentages? What do we get here if we add up? 85.35. 86. You guys got a calculator, so I would assume you guys could just plug it in. 84. 84 is correct. That's true. 84. 84 is correct. Yes. '84 is the correct answer. So, yes, 84. All right. Good. All right. That's talking about a normal distribution here, at least on a simple path. Again, the reason why I put the second example of more than 8 is because we'll see that kind of wording later on. So get a little bit of exposure to that. It's really not too bad, but we'll certainly point it out as time goes along. All right, good stuff. Okay. Any other questions before we move forward? Any other questions? No? All right. Okay. Let's take a gander here at the next part. Let's do it. Okay. Next one here is the last question here from the last handout. That is question number 11. Question number 11 says, what is Chebyshev's inequality? Now, I'm not going to spend too much time on this, but I'll just talk about it here. Now, this here is for, as I put here, this is for generic distributions, not for normal distributions. A normal distribution is a very unique type of distribution when it comes to statistics, okay? So it's its own kind of deal, right? So being a very unique type, it's not for every single type of distribution or data set you're going to get. But for generic distributions generically, for any data set or distribution, at least 1 minus 1 over k squared times 100% of the observations lie within k standard deviations of mean, where k is a number greater than 1. And written out that way. Okay. So if k equals 2, so within 2 standard distributions, if it was a generic type of distribution, all right, not just a special one like a normal, then essentially within 2 standard deviations, you would have 75%. So 1 minus 1 over 2 squared. 1 over 2 squared is 1/4. So 1 minus 1/4, which is 0.75. Take that, multiply by 100 to change it to a percentage. It would be 75%. Now we're not going to spend too much time on this here necessarily. But it is important to kind of note here because it does follow what we call the empirical rule. Again, empirical meaning like many tries instead of like think of like tens of thousands of tries as opposed to like 100. So what would it be in the long run as opposed to looking at a smaller sample size in some ways. We'll explore that a little bit more later on. But yeah, Chebyshev's, again, not going to spend too much time, but it is what it is. There it is. All right, good stuff. All right, let's move on. Okie dokie. Let's take a good look here at the next section here, section 3.3. Now, section 3.3 here is a brief overview for certain things. So let's just talk about it. Let's see how things go. It's really not too hard in any case. All right, how do we approximate the mean of group data? Okay, now what's the difference here in this case? In section 3.3, they do talk about group data. So group data means that if I had a frequency distribution and I just told you, it says, hey, 11 people got scores between 50 and 59, but let's say you didn't even have a data set associated with it. Let's say there was no data set, but you knew that 11 people got scores between 50 and 59. Well, this is going to help you solve for that mean here, because the problem is exactly as I stated. You don't know what the exact scores are. All you know is that 11 people got between, say, 50 and 59 on some random test. So for all you know, all of them could have gotten 59s, all of them could have gotten 50s, or, all of them could have gotten, majority of them could have gotten lower scores instead of higher scores within that particular class or category. Again, we don't know. So we need to essentially fudge the numbers just a little bit, because we do need to make some assumptions here since we're not given all the information. Now, in order for us to do that here, if we're going to find the population mean or sample mean here, all right, all we have to do is, let's take a look here at the formulas. And again, not too bad. I put them in notational format and wording format. So population mean here is the sum of the class midpoint times the frequency of the class divided by the sum of the frequencies. Okay. Again, in notational format, we have this mu, meaning to say, and then we have the sum of xi fi, again, xi being the class midpoint, right? And the fi being the frequency of the class. Sample mean works exactly the same way. Okay, there's no difference outside of the notation here, which we discussed last time, which was x bar. Now, the class midpoint here basically is fairly simple. Okay, so the class midpoint here is the lower class limit of class 2 plus the lower class limit of class 1, and dividing that by 2. Now, admittingly, what we're going to be doing here, as it says, is we're going to be if we're going to find the mean and to say the standard deviation and all that stuff, we're going to once again use the calculator in order for us to do that here, much the same way we did last time here for our previous example here for not group data, for just regular data and doing the mean and standard deviation. So we're going to go back to the well here and using one-var stats. So if you have your calculator here, once again, I would ask you to take those out. Okay, so please make sure you have your calculator in front of you. Um, there you go. So I guarantee you one thing here, Sarah, is that it'll probably be easier if I show you here via an example. I know this is more of the technical stuff here that I put here up on the screen. That's why I'm kind of going through this a little bit fast, because it's probably just easier if I just show you with actual numbers and seeing where this is applicable. So I'll show you what I'm talking about here. So I'm going to put up a new one here. All right. Let's make up a little charty chart boy. All right. So again, let's go back to the well here. All right. Here we go. Okay. So this is our scores. Let's say we have a frequency here. It's going to randomly make up some numbers here, guys. Okay. Let's say this is the frequency distribution. It looks just like this. Again, I'm randomly making up numbers as I go along. It is what it is. Now, for what we need to do here, if we're going to do this right, is before we do anything on the calculator, what we need to do is we first need to find the midpoint here of each class. Okay, so one thing we do need to know here is the midpoint here, because like I said, 11 scores between 50 and 59. I don't know exactly what those scores are since I'm not given that piece of information. So okay, without the exact data set, I'm not working off of much. So I need the midpoint here to kind of just basically kind of make a compromise here. So again, I'm going to take the lower class limit of this class here of 60. I'll add it to 50. And then I'll just divide that by 2 to get my midpoint here, which will be 55. Yeah. So that's what I have there. Next, I will have here, again, for the next midpoint, I'm going to take that next midpoint here up at 70. I'll add that to 60, and I'll divide that by 2. And I'm going to get 65. And you can pretty much guess what the midpoints are here at this point. I'm pretty sure that you can see what the pattern is going to be here. You get 55, 65, 75, 85, and 95. Now, I know you're looking at 95 here. Again, you would do 100 plus 90 divided by 2. Now, I know that seems a little strange, But the reason why I'm actually going to point this out here is because even though 100 is not necessarily a category here, a class, it would be the next class 100 to 109 if it did exist. So that's why I'm using 100 here. Even if that category doesn't exist, I am going to say, hey, each one has to have the same class width. We talked about that before. So I got to maintain the same thing here. All right. Okay, so let's take out our calculator here. Hopefully you have your calculator here. We're going to use this to our advantage. And let's see what we get. All right, so this is what we did last time. Okay. All right, so first and foremost here, let's go a little bit slow about this. So again, if you have your calculator in front of you, please type done in the chat so that way I know you are ready. So please type done in the chat if once you have your calculator in front of you. All right. Okay, let's go over this here then, since everybody has got it. All right, so once again here, we're going to go ahead and hit the stat key on your calculator. Hit the stat key here and go to edit. And check out our lists here. So stat and edit. Okay, now, once again here, if you do have existing lists from before, which probably you do from our last example last time, again, highlight the list and then hit clear and then hit enter. That'll clear out your last list here, just like so. All right. Okay. Next, let's go ahead and put in what we want in list 1 and list 2. Now, in list number 1 here, what we're going to do here is we're going to put the midpoints of each particular category. So we're going to put 55, 65, 75, 85, and 95. Oh, why did I put 89? That's so weird. 5. I'm not sure why I put 89. Even I'm kind of confused. All right. All right. Okay. All right, and then in list number 2, we're going to put the frequencies. So 11, 23, 19, 27, and 10. All right, so before I move forward here, please type done in the chat once you have this already set and ready to go. Okay. All right, done. All right. All right, very good. All right, so next what we're going to do here is we're going to hit second and mode to quit to the main screen. Again, just making sure that we don't enter in anything wrong here in our calculator. All right. We're going to go ahead and hit the stat key here once again. All right, so I'm going to type this chat here for next. Stat, calc, and then I want you to go to number 1, 1var stats. I know I'm green. There you go. So we're going to go here, 1var stats, just like so. Okay. All right, and you should see the submenu, or if you have the old school calculator here, then you should see 1var stats just appear on your main screen, just like so. Just 1var stats. Now, before we do anything else, let's make sure everybody's on the screen here. Let's type done in the chat once again, making sure everybody is on the same screen. Okay, good. All right, so let's take a look at what we see here on this submenu. On this submenu, if you have the submenu here, what you're going to see is list 1, L1, and then right below it, although we didn't use this last time, we will use it this time here, is the frequency list. Okay, we are going to use that here this time. Now, what that means is that we want to put something in that spot there. Specifically, we want to put list number 2, which talks about the number of frequencies we have in each class. So what you want to do is hit second and 2, which will be L2. And that should appear on the screen like so. And then you want to go down to calculate and hit enter. Now, for those of you who have the old school calculator here, what you'll need to do is, please follow on the screen here if the old school calculator, this appears on your screen here so far, is 1var stats. What you'll need to do here is you'll need to go ahead and do this, and I'm going to go ahead and show this off here on the calculator. Should look just like this, but just going through button presses. You should have 1var stats, and then you should have L1, so second and the 1 key, comma, so you do need the comma there. Second and 2, which is L2. And then hit enter. And then this is what we have here. This is what you should have here on the screen once you go ahead and do that just like so. Please type done in the chat if you have this on your screen. Make sure you have these same exact numbers here. Comma is right here, right above the 7 key, Alyssa. The comma is right above the 7 key. Should be that way for either type of calculator. It's always above the 7 key. And then remember, once you hit the comma key there, Alyssa, remember hit second and 2 for L2. Got it? Cool. Anybody else having issues or trouble? Please let me know. Please let me know if you're having issues, then we can work those out. Got it? Okay. Good. So, if you have this here, again, let's take a look at what we have up top. What we have up top here is we have the grouped data mean here. The mean here, in this case, is going to be 75.2 repeating. So that's going to be the mean here. In this instance, 75.2 repeating. And we didn't have to go through the painstaking process here. There you go. We are also given, again, just like we talked about here last time, the sample mean and population, the sample standard deviation and the population standard deviation. So the sample standard deviation here is given to us as 12.2683. And then the population standard deviation, again, slightly different because of it, the way you calculate it. 1.1999. Okay, so that's pretty much 2. Is the yeah, 7 bumps it up to 0.2. So, all right, and there we go. We got it. It's that is going to be our group data mean and group data standard deviation in both cases. Okay, very good. Alrighty, use the calculator just for that. All right, questions about that? Any questions? Again, type out your question in the chat, or otherwise type no, and I'll go ahead and move forward. Why is the population mean different? All right, so the population mean is different because in the formula here for figuring out the population mean, you're not subtracting by 1 in the denominator, so it's not n minus 1. So I'll go back here for just a moment. We can go back to this. We talked about it here. You're talking about just n as the sample size here, Vince. So n here is the population size, sorry. The sample size here, you're taking the sample size and you're actually subtracting by 1 here when you actually figure out the sample standard deviation. So depending on the perspective that you look over, Vince, it actually does affect the final result here. Again, are you viewing the people you're surveying as a population, or are you viewing them as a sample, that you're trying to extrapolate to a population? That's really the question that you have to ask. So when you make that determination there, then of course the way you calculate it is also going to change as a result. Hence why they're different in that. How do you clear L1? So the way you clear L1 is when you go to edit, you go to stat and edit, and you want to clear out a list. You highlight the list, just click up there, hit that up arrow there, Alyssa. Highlight the list, hit the clear key, and hit enter, and that will clear out your list. If you ever need some quick, that's a quick way to get out there. Sure, Vince. There you go. But there's no question 12 on this handout. The next question, this will be from the new handout then, if that's what you're referring to. This will be from this handout here. I'll put that up there like so. We'll be doing question 3 here in a second, so. Like I said, I'm not going to make you memorize it, but again, I'm just going to be like, hey, know exactly what this means, know exactly how to do it. It's really not too hard. It's just, being able to apply it at the end of the day. All right. Any other questions before I move forward? Oh, actually, probably do that before I do that. Alrighty. Okay. So, yeah, it's been about 55. Okay, so it's about 11:55. All right, so let's take a short break. Do you guys want to take a break? Is that, or do you guys want to keep going? It's pretty much about that time. Take a break or keep going, guys? Guys, let me know. Take a break. Okay. All right, let's take a break here for 10 minutes. All right, so let's take a break here for 10 minutes. We'll come back at 12:06. All right, so 12:06 we will come back. We'll take a 10-minute break, and then we'll continue moving forward here. All right, so we're working good here so far. So far so bueno. All right, let's look at what I gotta do next. All right, let's take a short 10-minute break, and we will be back. All right.
take me as I am. How can you see right through me? I've given you everything. Want you to just take me as I am. Take me as I am.
All right. Alrighty. I know we got a couple minutes here, but just getting set up and ready to go. Got a little. Yep. Alrighty, good stuff. Easy peasy lemon squeezy. Alrighty. Half-half. Alrighty. Hopefully everybody's getting back from their break. We're gonna go ahead and get started here with question number 3 here in just a minute. Hopefully everybody's had a pretty good weekend. Oh my goodness, 15! Psych Queen, thank you so much for the raid. Appreciate it very, very much. Hey, thank you so much, Psych Queen. That's really kind of you. Welcome to my math stream. There you go. I know that's not the most exciting thing you probably wanted to hear, but you know, we're here to learn. We're here to have fun. Thank you. Yeah, look. Oh man, thank you. If you're an educator as well, Psych Queen, I'm glad we're in the same boat together. We're always looking to pay it forward, definitely. Hoping to pay it forward with my students and stuff. Turn this down a bit. Hopefully to pay it forward. You're a psych professor. Wonderful, wonderful. Well, as you know, I'm a math professor, so I can appreciate that. Yeah, sure, Vince. I can, my friend. Let me scroll over here so you can read that. There you go. So how long you been a psych professor there, Psych Queen? I know. For me, it was a big change to come on here to Twitch. To be perfectly honest, a big change. Because of the pandemic and everything. So, a decade. There you go. Hey. I respect that. A decade's very, very good. A decade is absolutely outstanding. Outstanding. I've been doing this for a while now. I've been teaching in some capacity, Psych Queen, for nearly, wow, holy cow, 2 decades in some capacity. So yeah, I prefer it over Zoom, Psych Queen. I'll be honest with you, it's a lot more interactive in that way. Yeah, just in some capacity. I've been teaching math and I taught English for 4 years overseas. That's why I say in some capacity. I did a little bit in grad school, of course. So I preferred that than actually studying, to be honest. Like, here's a contract for teaching, you'll hate it. Like, no, I would rather do that than study, man. but if you're giving me a free ride and free money, I'm not gonna say no to that. Oh man. All right, ladies and gentlemen, we got to move forward here. All right. Let's talk about the next part here. Let's talk about number 3. We are back. All right. How do we find the z-score? How do we find the z-score? All right, let's talk about what z-score means. Now, z-score, admittingly here, ladies and gentlemen, is something that's going to pop up quite often here in a lot of different topics here when it comes to statistics, all right? But let's take a look at the basics here. Yeah, man, becoming an affiliate isn't that bad. I got to affiliate actually within the first like few weeks, so yeah, it was like a week or two. Oh yeah, you just need to put in the hours, but it's not too hard, in all honesty, Max. Um, how does it work here for z-score? So z-score here talks about the number of standard deviations a data item is away from the mean. So reading that carefully, the number of standard deviations of a data item is away from the mean. So here we see the formula here for z-score here, which is taking the data item minus the mean and taking that difference and dividing it by the standard deviation. All right. Now, one thing that you have to keep in mind here in regarding to a z-score, and this note here, is that it is okay to have a negative z-score. So we're going to get positive z-scores here. We're going to have negative z-scores. You could be any numbers. A data item could be any number of standard deviations away from the mean. Again, so positive or negative numbers are certainly acceptable here when it comes to finding these z-scores here. And essentially, the most important part here, of course, besides the notation being z or z times the z sub data item, is that every data item has a unique z-score. So no two data items are going to have the same z-score if they're different. If they're the same, then sure, of course they're going to be the same z-score. But if they're two different data items, then they're going to have two completely separate z-scores because of the fact of how you actually calculate out z-score here based on the definition. So let's go ahead and do a quick example here about, basic z-scores here. We're not going to be doing super crazy z-scores, but basic z-scores are fine. Now if I can find the, there we go. All right. So all we need is a mean and standard deviation. Let's take a mean here of, let's say 30. Let's take a standard deviation of, I don't know, 3. All right, so I'm just making these numbers up as I go along, but not too hard. So a mean of 30, a standard deviation here of 3, easy peasy. And let's say I wanted to find the z-score here of, let's pick a data item, let's say 37. All right, so if I pick the data item here of 37, I said, hey, can you tell me what the z-score of 37 is going to be? Well, all we're going to do here is we're going to plug in 37. Subtracted it by the mean here, which is 30. And divide it by 3. Alright, so here we get 7 over 3. And so here we get, what do we get here? 2.3 repeating. So 2.333. 338 to 33. Psych Queen. I don't know if you noticed what I just did there. That's also a little psychological trick. I was going to point that out there. So I don't know if you're still here, but hey, I love little psych tricks. It's super fun to use little psych tricks. All right, let's try another one here. Let's try 20. Okay, let's try 22. All right. So, if we take 22 here, can anybody tell me here, what would be the z-score here for 22? What would be the z-score here for 22? Other practice should be minus 2.66 repeating. Okay. Good. We have 22 minus 30 over 3. All right, so here we get negative 8 over 3. And if you do negative 8 over 3, we're going to have negative 2.6667. All right. Very good. There we are. All right, so that's correct, Father Prax. Absolutely correct. Again, I did take it to 4 decimal places because that's usually the MO of what we usually do here in a stats class is take it to 4 decimal places. So, but your answer is not wrong. I'm not gonna discount you whatsoever. But I do want you to notice here, once again, that we do get a negative score here. Okay, so we do get a negative score. That's perfectly fine. Now, what we want to be able to do, but yeah, did you notice what I did there, Psych Queen? Did you see what I did there? I don't know if it's pretty subtle. It's pretty subtle, but I use it's a little psychological thing that you can do that can really help out in the long run. So little things like that. I don't know if you noticed though, but we'll see. All right. Now the real question is, yeah, I'll point it out to you. The thing that I used in math a lot and what really helps is to be consistent. So this is what I can also tell the students this too because I use this all the time. One of the things I use in math a lot is I use parentheses a lot. And you notice I put parentheses around 37 and 22. Because of the way you use a formula here, you want to always put parentheses around what you usually enter in because usually the mean and standard deviation are static. So what changes? The change is going to be the data item. Because the data item changes, then therefore you put parentheses about what's actually always changing. Then essentially at the end of the day, it's easier to actually memorize that formula and actually put in where that changing number is always going to be by putting parentheses around it. And so it's those little things that help you to be more consistent in a very tough subject like mathematics. Believe me, with parentheses, it really helps out with a lot of different math concepts. So little subtle things, they really help out a lot in the long run. So I will point that out there. So I'm highlighting I'm highlighting where the changing of that variable is going to be, specifically those numbers. All right. So the real question is this. The real question comes down to, well, what are we going to do with these z-scores here? What are we specifically doing with these z-scores here? Specifically, what we're doing here with these z-scores is basically going to be relating these z-scores here with particular percentages, or in this case, percentiles. Now, they kind of introduced this topic really early on, and really we don't really use z-scores here a lot until later on. But, you know, for the sake at least you got to know what this kind of means here. You'll see more of this certainly later on in different topics here. We're definitely going to be doing a lot more with this. But let's talk about percentile here, because we will be using percentile here in the remainder of the chapter in some capacity. So we'll talk about that right now. So number 4, what does percentile mean? So the percentile refers to the data item is K. So that particular data item is K% better than all other data items in the data set. Okay, so we're going to relate this z-score here to a particular percentile and then be able to say, where does this rank in the data set here overall? Now, to kind of also put it into perspective here, let's do a simple thing here. All right, I like simple stuff because I'm just that dude. All right. So let's go ahead and put up a poll here. So I'm gonna put up a little poll here. You guys can answer this for me. All right. So did you take the ACT, SAT, or neither? Okay. So ACT, SAT, or neither. Again, it just varies from college and everything like that. So and region. So hence why I always ask. How do you take the SAT? Look up. So did you take the ACT, SAT? You know, you can pick one for the practice if you took both. I should have put both as an option, but you can pick either one. That's fine. If you pick neither, that's okay. That's okay. I don't mind. It's look. There's no judgment here if you did neither. So that's not a problem. No judgment whatsoever. Psych Queen, I'll look at your I'll click on your Discord link after I'm done here. So um alright, so alright, about 15 seconds left. Again, answer as honest as you can. It doesn't matter. Doesn't matter what you answer. Okay. I don't mind how you answer, so just a matter of, you know. Oh, a lot of people took the SAT. You know, back in the day, I took the ACT way back in the day. All right, so 9 people take the SAT, 3 people take ACT, 1 person neither. Yeah, I took the ACT back in the day. Now, if you took the SAT or ACT, regardless of which one of those tests that you did, all right. Now, you probably got a score report at the end of the day. Now, let's take the most popular one here, the SAT, for example. If you got the SAT, then of course you're scoring those 4 categories, and they give you basically a little run profile about how you did on each of those categories. Now, they put a percentile about how you ranked with other people who took that same exact SAT. So they give you, hey, how did you do? So it's like, let's say you did really well on a section. He says, I scored in the 97th percentile. What that means is that you scored better than 97% of the people who took that same exact SAT test. Same thing with the ACT. They break it down since it's out of 36. They like break it down in those categories and they say, okay, your score in this category ranked in, let's say mine was like, you scored this in the math one, so you scored in the 90th percentile, for example, and there you go. You scored better than 90% of the people who took that same exact ACT test or SAT test, regardless of whatever the case may be. Honestly, full disclosure here, I took the ACT. I took the ACT 2 times. I got a 22 the first time, got a 25 the second time after taking a prep course. So, yeah, that was a. Believe me, guys, I'm not the best student in the whole wide world. Okay, that ain't happening here. That's not what this class is about. All right, but 25 was pretty good, so I was fine with that. I was fine with that. If only I could write English papers. All right, so yeah, that's basically what percentile means also in statistics, is where that data item actually ranks in comparison to all the other data items as well. Now, where is that going to leave us here? That leads us here to talking about quartiles. Let's talk about quartiles. So what are quartiles here? So quartiles here are going to talk about, we're going to talk about Q1, Q2, Q3, and Q4. Okay, so here we have, again, when we talk about Q1, Q2, Q3, and Q4, we talk about the 25th percentile, Q1, Q2 being the 50th percentile, Q2, Q3 being the 75th percentile, and Q4 being the 100th percentile. Now, of course, as you can see here, based on the definitions, we don't actually use a couple of these. Q2 being the 50 percentile is the median of the data set. Should be pretty comfortable with the term of median at this point. And Q4 being the 100th percentile is just the highest value in the data set, so nothing that's going on there. The two that we're going to clue in on here in this case is going to talk about the 25th percentile and the 75th percentile, i.e. Q1 and Q3, and about how to find those specifically in a given example. So let's go ahead and take a look at that now. All right. So let's do a little simple stem and leaf plot here. And we're going to, by the way, we're going to re-explore this stem and leaf plot again, as we probably won't finish chapter 3 today, but certainly be using this example once again. Let's look at stem and leaf plot here. All right. So the stem here is, let's go with the certain stems here. I'm just going to write down some numbers here. Okay, good. 5, 7, 3. Let's go with 7, 9, 4, 2, 4, 5, 12. All right, here we go. All right, so let's say these are our numbers here put in place. Let's go ahead and take a look on how we can go ahead and find Q1 and Q3 based on this stem and leaf plot we see up here on the screen. Now, it's not too hard. I can guarantee that. It's not too hard. It doesn't take too much time, but let's look at it step by step on how to find Q1 and Q3 here, at least in this process. So the first thing that we're going to do here, let's talk about step 1. Step 1 here is we need to find the median. Now notice we've already went ahead and put this in numerical order. Just as a reminder here, remember that 0, 2 represents the number 2, 0, 7 represents the number 7. All right, so first we're going to find the median. All right. Now, can anybody tell me here, how do I find the median of a data set? What do I do first? How do I find the median of a data set? What do I do first? And divide? Not quite, Father Prex. And divide. Add up all the numbers, that's finding the mean. Alyssa, you're thinking about finding the mean there. I want the median. Sum of the middle numbers divided by 2? Guys, what are we forgetting here? How do I know what the middle numbers are? What are the middle numbers, guys? I'll go back, look at your notes. What is the first thing that we did when we found the median, guys? Because I don't know what middle numbers you're talking about. I see a collection of numbers there. Find the top number and bottom number? Not quite. All right, to be fair, Alyssa, that's true. But I now have them in order. They are in order. So what do I do after that? So I agree with you, Alyssa, 100%. You're correct. You put them in order first. What comes after that now? Father Prax, you're thinking about range there. You're talking about bottom. Find out it's even or odd? What are we trying to do if it's even or odd? The median is 26? Well, that's great. But so one of the things I'm going to stress about here, Vince, is that I want you to tell me the process about how to find that. Because the one thing I want to kind of remove here is I want to remove the guessing, right? Because it's like, well, if I tell you to find the median about anything, you're like, well, you're just going to stare blankly at me, or you're going to be like, well, I don't know how to do that. So when we found the median here, what was the thing that we did after we went ahead and ordered the data set? Yeah, so what was that called, Vince? You're getting very close. All right, so how did you know those were the middle two numbers? Position of the median, very good. Okay, so all of you kind of going around that answer there, okay? But yes, I was looking for that there. Alyssa said, let's find the position of the median. And then I am going to use here, and I totally agree with all of you, it would be the number of data items in the data set. So exactly, Father Prax, count of the data set there. All right, total number of data points in the data set plus 1 divided by 2. 100% correct. So again here, we're going to find the median here. We first got to find the position of the median here. All right, and again, position the median here specifically, as is correctly pointed out by everybody here in the chat, 100%. Let's go ahead and do that right now. Position the median here is going to be n plus 1 divided by 2. Okay, where again, as we know here, n is the number of data items in the data set. Okay. All right, so I agree with all of you here. I just wanted to be able, you guys, to point out position of the median here. Again, that way we're taking away the guessing. We know exactly where the median is going to be within this data set. So no guessing, just doing. That's what we want to do. So as was pointed out here, how many do we have? We have... How many data items do we have in the data set? What's our n here? I think it was said earlier, but... yes, okay, good. We have 18, that is correct. Good. So we have 18 plus 1 divided by 2, that's correct. Okay. And so that's 19 divided by 2 here. So everybody would agree we get 9.5. So 9.5 is where we're going to find... The 9.5 position is not the median. That's just where we're going to find the median, right? Again, for smaller data sets, I agree. It's significantly easier, okay? But if it's a large data set, you want to find exactly where that's located without having to do too much work. Imagine trying to find it by hand if you had 1,000 of these numbers. You can see why finding the position here is wanting to be significantly easier, because then all we have to do is look for, say, you know, we have to look for the 500 and a half number, and we could go ahead and do that if there's 1,000 numbers, for example. All right, so let's take a good look here. Thank you, Baku. Appreciate that. All right, so let's count 9.5 here. We're doing statistics, my friend. All right, so let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9.5. So 9.5 here will be right where this arrow is located. Okay, so where this arrow is located, that is where the median will lie. Now, as we know here from before, all we need to do here, and Vince actually pointed this out earlier, so I'm going to follow suit here in this case as well, is we're just going to go ahead and say, hey, we take the mean of the two numbers around, because again, realistically, there's no number in the 9.5 position. That part is true. So again, we're going to take 25 plus 27 and divide it by 2. And so here the median is 26. All right. All right, any questions about that? Hopefully that's not too hard now. Okay. Any questions? No? All right. Okay. Move here to step 2. All right. So let me point out why this was so important in the first place. Now there is a reason, okay? So it's not like I went through this painstaking process, got you to find the position, all this stuff. This is actually really important. Why? Because if we're going to find Q1 and Q3, let's look at the definitions, and then step 2 is going to make a whole lot more sense once you look at that here. So Q1 here is the quote-unquote 25th percentile. The definition of Q1 is the median of the data set that is to the left of the median. So the median of the data set that is to the left of the median. Now you're probably saying, but you're saying median twice. You're like, yeah, I kind of am. But read it carefully. The median of the data set that is to the left of the median. All right? That's what we're going to do next. To do this in order, to do this in proper order, first want to find the median. Then we want to find Q1. And to find Q1, we're going to circle the data set that is to the left of the median. Okay? We're going to circle the data set that is to the left of the median here. So notice where I put this purple arrow. This purple arrow, as we all can agree, is where the median is located. Now I'm going to circle all the data items in the data set that is to the left of the median. So I'm going to go here. I'm going to circle all these guys. This is, my friend. You're more than welcome to join. All right, so notice here what's happened. I've circled all the data items to the left of that purple arrow. Again, I want you to see this from a pictorial representation because again, at the end of the day, nothing to be. Don't apologize, my friend. It's perfectly fine. So you can see that all the numbers there to the left of the purple arrow are all the data items to the left of the median. So that's why, again, I want you to visually be able to see it, so it's easier for you to go ahead and find that by hand. So now, all I gotta do is find the median of all these circled data items. And I'm just gonna go, again, this is, again, another reason why I asked you these questions here more specifically. I said, hey, I need to find now that position of that median of the data set to the left. So I'm going to count how many data items I got. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9, I have 9 data items in the data set that's to the left. So this one here, admittingly, is going to be significantly easier to find. Because again, if we're talking about the position of this median, position of Q1, or I guess I'll say median. Position of that median will be 9 plus 1 divided by 2. So it should be in the 5th position here. Let's find out where that is. So let's count 5 numbers. 1, 2, 3, 4, 5. And so the number here that's going to be our guy will be 18. So 18 is going to be our Q1 here in this case. Yeah, I just opened up this channel here, Father Prax, for anyone to learn. So, although this is, technically my official class, I just, I think if anybody wants to better themselves and they want to get to know something that may help them in the future, why not? I don't think that's such a wrong thing. Okay. Any questions about Q1 before we do Q3? So 9 is because the number of data items in the data set that was to the left there, Alyssa, of the median. So notice what I circled there, Alyssa. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So how many numbers do I have to the left of the median? I have 9 numbers. That's why I circled it in red, so I don't have to guess. I can just visually see how many numbers are to the left of where that arrow is going to be. And in this case, Alyssa, there were 9 numbers to the left. Does that make sense there, Alyssa? Let me know if you have another question about that. Okay. All right. I'm going to do one more part here because we're almost out of time. But, all right. So the last part here is to find Q3. Let's find Q3. Okay, so Q3 basically is, based on the definition here, as you could probably guess what's going to happen here, is the median of the data set that is to the right of the median. Okay, so instead of looking left here, if we're looking at the 75th percentile, we want to look at all the data items to the right of the median here. And so we'll circle this in blue. Okay, and so that will be all these data items that are to the right of, not including the median, of course, but again, right of that purple arrow. All right. So we can count it out. We get, again, it's a tad bit bigger now. All right, so we have, again, 1, 2, 3, 4, 5, 6, 7. Yeah, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 numbers here to the right as well. I almost counted that. All right. So again, the position of that median here is going to be, once again, 9 plus 1 divided by 2. Probably guess is the 5th position. Yes, that's exactly right. They're actually positionally based and not value based. That's correct. So people think it's Q4 is value based because it's the highest value in the data set. That part is true. But Q1, Q2, Q3 are positionally based on the ordered data set. Only Q4 you can actually probably make that claim because it's just the highest value in an ordered data set. So let's go to the 5th position here. We got 1, 2, 3, 4, and 5. So right here, my good friend, 39 is going to be our Q. Yeah, that's why I don't want to make assumptions about what the numbers are there, Father Prax. I want to use the definition and actually find it for myself. And if I can visualize it, it makes it that much easier. So that's the way I kind of like to approach those. All right. So that's about Q1 to Q. That's about quartiles there and everything like that. All right, we ran a little over time here, but not too bad. All right, any questions about today? By the way, we're gonna continue moving forward here for next time. I didn't get through everything I wanted to, but you know what? It did take quite a bit of time, so that's fine. I don't have a problem with that. Again, it's purely based on your pace here. So we'll finish up chapter 3 here for the next go around. So that'll be what will be on the docket here for Thursday. But I'll come back and use this example or use a similar example here, and we'll go through the process here because we need to get a few more tidbits of information. So I would hold off on 3, 4, 3, 5 for right now. I'll probably just do 3, 2, 3, 3 today. If you're trying to keep track. So section 3.2 and 3.3. We will be talking, Vince, here for next time. We'll be talking about box plots. And how to construct a box plot. So in order for us here, how come we skip the Q2 step? Great question, because we already found Q2. Remember, in this case here, Q2 is the median itself. So we actually find Q2 before you find Q1 and Q3, because we need to know exactly where those positions of Q1 and Q3 are. So actually, when you find the median, this is automatically Q2 by definition. You talk about 50th percentile, straight down the middle. That's what it is. We actually did not skip Q2. We actually did it first here as part of our process. All right. Any other questions you may have? I hope everybody fine. All right. Very good. Very good. All right. Nope. All right. Well, I want to thank you all for coming out of your stream today. All of you, absolutely fantastic people. Thank you so much, everybody, for coming out of the stream. You guys are all what make this this stream absolutely fantastic. You know, I don't know what else to say. I have no words about what to say. I have Sight Queen come in with a wonderful way and with a wonderful community. Thank you so much for that, Father Prax. Thank you for participating. I like the fact I like people who participate and add questions and want to get things cleared up. I'm more than happy to be educate you as best as I can, You guys, thank you so much for today. I know today was a little slow, but I don't know if you guys are comfortable with that pace. I just hope that you guys were able to understand what was going on here today. So again, I like the fact there's gonna be days like this, guys. We're just gonna be going slow over the material, but that's not a bad thing. Remember, it's all about you and making sure that you guys understand what I'm selling. So, want to be sure that you guys are all on the same page at the end of the day. So, if you don't get through everything, that's not a big deal to me. It's again, ask as many questions as you like. I'm really happy with your participation today. You guys were fantastic. Next time, like I said, we're going to be going over box plots, so we're going to be coming back to the stem and leaf plot example for our next go-around. In the meantime, ladies and gentlemen, thank you again very much. All of you are fantastic. We're going to come back here on Thursday, okay? Thursday, same time, same place, everybody. Thank you very much again. And as always, everybody, I love you all. As always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right? Have yourself a wonderful day, and we will see you again on Thursday. I'll be back online here at 4 o'clock here, a little bit later on today, for Math 102. But in the meantime, if you guys have questions, I'll be on Discord, or I'll be you guys can ask me via email. All right, have a great one, everyone. We will see you all later. Take care, everybody. Have a great one. All right, see ya. Bye. Bye, everybody. We'll see you later.